Hello guys, today I'm going to show you how we can solve this problem, contiguous array. The problem statement says that we are given a binary array and we need to find the maximum length of the contiguous subarray which contains the equal number of zeros and ones. So for example, here the largest such subarray is the whole array itself. In here, the largest such array can be either this one or this particular part. So let's see how we can solve this one. Let's understand that we are given this array where these red blocks are indicating 0 value and the green blocks are indicating value 1. So what are we supposed to find here is the maximum size of subarray where the green blocks is equals to the number of red blocks. So if we try to look this problem a bit differently, we can see that there are only two elements which are given here. I mean, there are only two kind of elements which can be present in the array, and instead of treating this one as 0, if we consider this one to be, for example, -1 instead, let's just remove this one and place a -1 instead, like so. All these blocks which are represented by red color are treated as a -1 value. So what then we need to find is a subarray where all the sum of the elements of that subarray is equals to 0. So basically what we need to find a certain array where the sum, a certain subarray where the sum of all these elements is equivalent to 0. So now we change this problem to a different problem where we are supposed to find a subarray where the sum of all the elements in that subarray is equals to 0. So there can be many such subarrays, and we need to find the largest such subarray. So we can use the prefix sum, which I have explained in other video, to find out such subarray whose sum is equals to 0 or its sum is equals to a given target. So I'll share the link to the video in the description below. You can watch that video. What I'm going to explain here is how we can use that particular method to find the largest such subarray. To give you an overview of what the prefix sum method is, we are going to maintain a prefix sum and we are going to record each prefix sum into hash map. What is a prefix sum? Prefix sum is the sum of all the elements starting from 0th index till a particular index I. Let's say if we are at this position I, this index, this ith index, then a prefix sum will represent all the sum of elements from 0th index till this index. And what are we going to do with this prefix sum? We are just going to record each of these prefix sum into our hash map. So hash map of current prefix will be recorded, and prefix will be a key and value should be the index at which this prefix sum is found. How is it going to help us? So whenever we will see a particular prefix sum which is already seen, then let's say for example we have seen this particular prefix sum which is x, and some moment later we saw that there is another prefix sum whose value is x again. And this can happen because we are having -1 in between, so the prefix sum can go down and go up and then reach to this particular sum again at some point of time. So let's say till here we found another prefix sum whose value is equal to x. So now we know that all the elements sum from this to this will have to be 0, because if this is a and this overall is b, then the sum of these elements will be b minus a. But here both of them are same, so the sum of these this particular part is going to be 0. So let's say if this is y, this should be 0. So now what we can say is that we recorded the index at which this particular prefix sum was found, and we know the current index, so we can just reduce the index, I mean I minus this particular index, and we can get the length of this particular subarray. So we know that we have found a subarray whose sum is going to be 0, and that's what we needed to know, and we also can find the length of this one. And as we said that there can be different such subarray whose sum is going to be 0. We will just compare the length by just keeping track of all the previous length that we have found till now. I mean keeping track of all maximum of all the such length that we have find. So if this particular length is bigger than the previous one, then we will update our answer. So yeah, this problem becomes very easy if we just turn this one from 0 to -1, which was very tricky to find. So here is a giveaway from this approach, that we can apply the same approach for any similar problem where we are given, let's say, a different I mean in this one we saw that there are only two kind of element. One is 0, the other one is 1, and if we are given any two different values, let's say x and y, we can simply treat x as -1 instead of 0 and y as +1, and what we just need to find is the largest such subarray whose sum is equals to 0. So now let's have a look at the implementation part of it. So I've declared a hash map. As we discussed that we need this hash map to store each prefix sum and the index of it, and then we have inserted the first pair as 0 -1, so that if at any moment if our prefix sum itself becomes 0, then we will be able to catch that as well. That means for example, if at any point, let's say here, we saw that this particular prefix sum itself is 0, then we know that the whole subarray starting from 0 itself is one valid subarray. So if we record -1 here, we will be able to catch the we will be able to calculate the index, the total length of this subarray. So let's go back to the implementation, and then as I said, we will need a prefix sum, and we have initialized our answer with a negative minus infinitive. So as I said, we are going to treat 0 as -1 and 1 as 1 itself. Then we will add this particular sum to the current prefix sum, and we check if this sum is already seen or not. If this sum is already seen, then we have found a valid subarray, and then we are going to get the compare its value, compare the answer's value with the difference of the current index minus the value stored at this particular sum. And if this was not the case, then we have seen a new such prefix, and we are going to record this particular prefix into our hash map. And in the end, we will check whether our answer is greater than 0 or not. If it is not greater than 0, then it means there is no such subarray which is having equal number of 0 and 1s. So in case if it was having all the 0s or all the 1s, then we would not have any valid such subarray. So alright, so I hope you enjoyed the explanation. Thanks for watching this video. Please subscribe to my channel.